Hello everyone, my name is Akram Mustafa and I will be presenting our work titled Reasoning Large Language Models for Clinical Coding. This research was conducted in collaboration with Dr. Usman Naseem from Macquarie University and Professor Mustafa Rahimi Azghadi from James Cook University, and to be presented at the BioCreative 9 workshop at IJCAI 2025. To give you a bit of background, accurate ICD-10 coding of clinical narrative is critical in healthcare for billing, research, and planning. However, this process is mostly manual and time-consuming and prone to human errors as well. With the rise of large language models, there is a growing interest in automating medical coding to improve efficiency and reduce costs. Our objective is to evaluate whether reasoning-enabled LLMs perform better than standard LLMs in classifying ICD-10 codes from hospital discharge summaries. Specifically, we wanted to see how reasoning capabilities impact accuracy across different levels of code granularity. Previous studies have shown mixed results. For example, GPT-4 and Llama 2 struggled with exact code matching in clinical tasks, often generating invalid codes. This motivated our focus on reasoning LLMs, which are designed to better interpret complex narratives by linking symptoms, procedures, and diagnosis. We framed three key research questions. First, can LLM match or even exceed human coders in accuracy? Second, do reasoning LLM provide measurable improvements over non-reasoning models? And third, does performance vary across levels of ICD-10 details, from broad categories to highly specific codes? To answer these questions, we conducted a comparative evaluation of 11 different LLMs. We used a zero-shot prompting strategy and tested the model on multi-label classification of discharge summaries from Mimic4 database. The models we tested, including 5 reasoning LLMs such as DeepSeek Reasoner and Gemini 2.5 Pro, and 6 non-reasoning models including GPT-4o and Llama variants. This diversity allows us to compare reasoning-enhanced models with more conventional ones on the same dataset and task. Our dataset consisted of 1,500 discharge summaries from Mimic4, covering 10 ICD-10 codes. Each summary could contain multiple codes, making this a multiple classification problem. We pre-processed the text using ctakes to extract clinical entities and normalize terminology. We evaluated performance using a fun score, which balances precision and recall. We examined 2 coding contexts, primary diagnosis and all diagnosis, and 3 levels of ICD-10 granularity, level 3 for general categories, level 4 for mid-level, and level 5 for highly specific codes. Overall, reasoning model consistently outperformed non-reasoning models. Performance improved as codes became broader. For example, Gemini 2.5 Pro achieved an F1 score of 39% at level 3 for all diagnoses, but only achieved 7% at most specific level 5 codes. Looking closely at individual models, DeepSeek Reasoning achieved 31% F1 score at level 3, while Gemini 2.5 Pro led with 39%. In contrast, the best non-reasoning model, GPT-4o Mini, scored 24%. This demonstrates that reasoning capabilities provide a consistent advantage, especially for broader classification. These findings suggest reasoning model can better interpret complex clinical narratives, linking multiple pieces of information to relevant codes. However, both reasoning and non-reasoning models struggled with highly specific coding, indicating that fine-tuning or hybrid approach may be necessary for higher accuracy. Our study had some limitations. We only used 1,500 summaries focused on 10 codes, and we relied solely on zero-shot prompting. The results therefore may not be generalized to all ICD-10 codes or real-world coding environments, where broader context and domain fine-tuning are available. In conclusion, reasoning LLMs like Gemini 2.5 Pro and DeepSeek Reasoner show clear promise for automating ICD-10 classification. Future research should expand to larger datasets, including fine-tuning for medical text, and explore hybrid system combining LLMs with rule-based coding to improve specificity and reliability. Thank you for your attention. I'd be happy to take any questions about our methodology, results, or future work.